Alright, so this is your extra chapter review. To do this, I would probably go ahead and try each problem on your own first, and then check with the video. And if you get it wrong, I'd go back and listen to me go through it, so then you can kind of figure out where you went wrong and that kind of thing. So, for this first problem, it says graph the following function and state domain and range. So don't forget to state the domain and range in the end. So number one, the biggest thing is, when it says graph, all your quizzes and tests are graphing calculator. So I would just go right away and plug this in my graphing calculator. So go to y equals, and we had, let's see, negative, so we need negative, and we're doing x minus 6 squared plus 2. So now make sure that your 2, your whole squared part is all together, plus 2 is outside of any parentheses and such. And when you hit graph there, now my window's a little bit messed up, so if your window's messed up, you should hit zoom and go back to the standard window. And then that should give you kind of a general outline of where it is. Now I need to figure out what points on here I want to go ahead and plot. That's where you have to go to the table. Now, first thing you're really looking for in the table is you're looking for symmetry. So here, if I scroll down, I'm starting to see numbers repeat. So I should know that, oh hey, the only one that doesn't repeat is 6, 2. So that must be the vertex. Well, here's another way to find that vertex without using your calculator. Whatever is raised to that power, take that, set it equal to 0. So x minus 6 equals 0. Add 6, you get x equals 6. This should be the center of your table. Well, we already confirmed that. It is the center of my table over here, 6, 2. So make your table x, y, and put 6, 2 in the center. Choose some points below it and above it. So 6, I'm going to do 7, 8. So looking at my table, 7 goes with 1, 8 goes with negative 2. I'm going to choose 5 and 4. Well, 5 goes with 1, 4 goes with negative 2. Again, I'm just grabbing the center of my table here. And now I just need to plot those points. So I have 4, negative 2, 5, 1, 5, 1, 6, 2, 7, 1, 8, negative 2. And finally, put that U shape in there. Now remember when we're talking about domain and range. Well, domain, we're going from left to right. So left to right. Well, the first thing I hit is that arrow down here. That means I'm going to negative infinity. And then if as I go continue, I'm going to hit an arrow at the end as well. So I'm going to have everything covered in this function. Range, I'm going to think, hey, I need to start at the bottom and work my way up. Well, the first thing I hit is those 2 arrows. So again, arrows going down go with negative infinity. And then the last point I hit is actually going to be this critical point up here. Now range, remember we're talking about y values. So then the highest y value is 2. And I include it because that is going to be on the graph. Alright, so those are some tips to kind of going through domain range and how to graph. Always basically get a table of some sorts. Alright, if the graph of f of x equals the square root of x is translated 3 units left, so 3 units left, remember that that actually is going to be plus 3, and that's the thing that goes on the inside of your function. So that's going to go in the square root. 1 unit up, that remains the same, plus 1, and that goes outside. And we have a reflection. Anytime there's a reflection, you think negative. We need to make it the opposite equation. So adding these things together, we need f of x equals, well, I reflect it, square root x plus 3 on the inside, and plus 1 on the outside. So that tells me I'm reflecting, I'm going left 3 and up 1. So again, now let's work backwards here. the original function is the square root of x now. So I need to identify the things that are happening. Well, negative, that tells me my reflection. This x minus 2 in here, well, you should think the opposite. It should be 2, and since it's inside, that tells me left and right. Well, since it's the opposite, it's 2, I'm going 2 to the right. And then finally, I have a value outside here, plus 3. That tells me up slash down. Well, it's positive, so I need to go up 4. So putting this all together, what do we end up with? Well, the graph of f of x is shifted right 2 units, up 4 units, and reflected over the x-axis. It's always going to be a reflection over the x-axis. Right? So that's kind of all the things that deal with different graphs and translations. So now let's move on and talk about those combining and composition. So here I have f plus g. So that tells me I'm adding f plus g. So I need to add these two functions, f of x and g of x. And then I need to make sure that I'm evaluating at negative 4. So there's a few ways you can do this. You can combine these first and then evaluate, or evaluate each of them. So here, I would go ahead and say, hey, what's f plus g is going to be x squared plus 1 plus 2x plus 3. Well, you can simplify x squared plus 2x plus 4. And now I need to put negative 4 in. So negative 4 squared plus 2 times negative 4 plus 4. Well, that's 16 plus negative 8 plus 4. Well, 16, that's 8 plus 4, which ends up being 12. Again, you could do negative 4 squared plus 1, which is 16 plus 1, 17, plus 2 times negative 4 plus 3, which equals negative 5. Add those together, you still get 12. Both ways are valid. Now, here's where you got to be careful here. This here is not multiplication. And this is where a lot of you messed up on the first quiz. So you got to be very careful. This is composed. So really, this is saying f of g of 1. So start with whatever g of 1 is. G of 1, well, that's 1 minus 1, which is 0. So I'm going to replace g of 1. So g of 1 is 0. So g of 1 is 0. So take f of, well, 0 now. So that's 0 squared minus 0 plus 1. Well, that just equals 1. Alright, so let's continue with a few more of these. Again, I have a composition here, but now my order is changed. This is saying, hey, I'm taking g of f of negative 3. So start with f of negative 3. Well, take negative 3 squared plus 2 times negative 3 minus 4. So I've got 9 minus 6 minus 4, which is 3 minus 4, which ends up being negative 1. So now I know f of negative 3 is negative 1. So I need to do g of negative 1. So I have negative 1 minus 2. I get negative 3 as the answer. Now here's where you got to be careful. This says, hey, f composed of g of x. All that means is take g and put it into x. So again, this is going to be f of g of x. Well, what is g of x? This is g of x. So I'm taking that, I'm putting it into f. So f of g of x equals 3, put in 3x plus 2 over 3, and subtract the original 2 from f of x. Now here, a lot of you want to distribute this, but if these two match, they go away. And same thing, if you did this, you could do 3 times 3 is 9, 3 times 2 is 6, divide 3 out of both of those. Again, they cancel out. So you get 3x plus 2 minus 2, which ends up as just 3x. Right? So that's all the composition, the combining. Of course, there may be some that are adding, there may be some that are subtracting, and multiplying, but those are some key ones I wanted to go over. Alright, so now this is the new stuff that you just had a quiz on. Find the inverse if we determine that the following is invertible. So what are we looking for here? We don't want no repeating x's and y's. So here, -3, -2, -1, 0. No repeating x's, we're good. 3, -2, 0, 2. We're good. So yes, invertible. So to invert it, we switch x and y for every pair. So switch x and y, we get the set of 3, -3, switching them. Now -2 stays the same. 0, -1, and 2, 0. And that's our new set. That's the inverse here. Alright, but what if we're not looking at a set of points? Let's look at some equations instead. Remember, first step, change out f of x with y. So y equals the cube root of x minus 1. Now, switch x and y. So x equals the cube root of y minus 1. If I want to get y alone in the end, that means that I need to do inverse operations to get y alone. To get rid of this third root, I need to cube all of the sides. So x cubed equals y minus 1, because cubing takes away the square root. Finally, add 1. Add 1, we get x cubed plus 1 equals y. But we need inverse notation. F inverse of x equals x cubed plus 1. Now, because I have an odd in the end, there's no restriction necessary for this one, so I'm done. If this was even, I would need a restriction at the end. Alright, this is the one that we did yesterday in class. Inverses, you gotta be careful with them sometimes. So y equals x minus 4 over 2x minus 1. Switch x and y. Y equals, x equals y minus 4 over 2y minus 1. If there's a y in the top and bottom, multiply both sides by the denominator. And don't forget to distribute your x in. 2xy minus x equals y minus 4, because we got those to go away. Here's where we had some trouble. Get y on the same side. Subtract y, subtract y. 2xy minus x equals -4. But these y's need to be alone, so add x to both sides. We get 2xy minus y equals x plus 4. Now, be careful here. If y is alone, when you take y out, it's 2x minus 1. It's not gone there is still a 1 here. So don't forget that there's a 1 there. X plus 4, and finally dividing both sides, we're going to end up with y equals x plus 4. Oh, that should have been minus 4. That shouldn't have changed. Minus 4 over 2x minus 1, which is really f inverse of x equals x minus 4 over 2x minus 1. Oops, sorry. And again, this is one of those funky ones that ends up being the same as it started, but not always going to happen. Alright, what about graphing them? Again, if it gives you a restriction, that means, hey, take your table and start there. Start at 2 and just move up from 2. So 3, 4, 5. Now, it says find the inverse. So do that first before you even actually evaluate here. So I'm going to do y equals x minus 2 squared minus 3. So x equals y minus 2 squared minus 3. Before you square root both sides, add the 3. X plus 3 equals y minus 2. Now you can square root both sides. So square root of x plus 3 equals y minus 2. And finally add 2. Now the 2 does not go on the inside. We have x plus 3 plus 2 on the outside equals y. But really, this is going to be f inverse of x. No restriction because I didn't end with an even root. And when I graph this, all I'm going to do is switch this table from above. So let's graph the original. Pop it in your calculator. Go to y equals. I've got x. Let's clear out. So we've got x minus 2 squared minus 3. Let's just go straight to the table here. Well, I know I wanted to start at 2, so I better start at 2. 2, negative 3. If I did 2, negative 3, now I got 3, negative 2, 4, 1, and 5, 6. Again, we'll plot those points first. So 2 down to negative 3, 3 down to negative 2, 4 up to 1, and 5 up all the way to 6. Parabola, only half of a parabola going up. And notice how it passes both the vertical and horizontal line test. It should. Now let's flip those points and graph the inverse. Negative 3, 2, negative 2, 3, 1, 4, and 6, 5. So negative 3, we're going up to 2. Negative 2, going up to 3. 1, so positive 1 up to 4. And 6 up to 5. And that should be that half a parabola on its side. So then we got our inverse in black, and we've got our regular in blue. Alright, now let's finish it off with some good old variation. So direct, inverse, joint, combined, or none. Well, look, up here I've got direct, just one set of multiplication. But here I have inverse, because I'm dividing by a variable. So I have combined in the end. As soon as there's more than one type going on, it's combined. Alright, find the variation constant if A varies directly, so equals directly, so K, as X, and inversely, so I need to divide by Y. So I've got directly as X and inversely as Y. So A equals Kx over Y. So now I know that A is 2. So I've got A equals 2. And now X is 1. So we've got K times 1 all over Y equal to 4, so over 4. Well, to solve for k, I just need to multiply both sides by 4. So k equals 8. And that's all it wanted me to do, is find the variation constant. Alright, and finally we've got the different one using variation, but it's a word problem. So it says the labor cost of installing a ceramic floor varies directly with the length. So directly, we're going to multiply by the length, and inversely with the width. So inversely means I'm going to divide by the width, W. So right away, just go ahead and set up an equation first. Cost, I call that C. So C varies directly with L, the length, and inversely with W. Now, it says, hey, labor cost of a 9-foot length, so L equals 9, and 12 width floor, the cost is $324. So now, put that into your equation. 324 equals our constant times the length over the width. Well, hey, we got to solve this now. So multiply by 12, multiply by 12. So 12 times 324 is 3,888 equal to k times 9. Divide by 9. We get a value of k that equals 432. Now, it says, hey, what is the cost of installing a 16-foot by 12-foot room? So that's length by width. So hey, what's the cost now? Cost equals, well, k is 432 times 16 over 10. So 432 times 16 and divide it by 10, you get $691.20. 20 if we want to be accurate about money. So that is a snapshot of everything that is on your test tomorrow. What I would do, if you haven't already done, I would make sure you do that review packet so that you have that too as review, and you should ace the test tomorrow.